we thought it would be really nice to show the actual launch of ICESat-2. It seemed like this just happened yesterday, but actually it happened on September 15th. So we're going to play this for just a minute or so because it's actually really cool and quite motivating. So yeah, here we go.
Okay, Melinda, just let me know if you cannot hear the audio.
I can't hear anything. But we can see it.
Research and exploration missions putting ICESat-2 on a quest to explore the polar ice sheets of our constantly changing home planet. "27 seconds into flight. 30 seconds in, Mach 1, Delta 2000 sonic. Continue to see good chamber pressure on the R27, so good your engine as well. Seeing consistent fuel and oxidizer injection pressure as well. And T plus 46 seconds, max Q, maximum dynamic pressure. And 57 seconds in, we have web burnout on the solid rocket motor. Good response. And we have burnout on all 4 motors. And Delta will hold on to those motors for an additional 20 seconds prior to jetting. Now 1 minute, 20 seconds in, standing by for motor jet. And we have good indication of jettison of all 4 solid rocket motors. Now 1 minute, 30 seconds into flight.
Okay, I'm sorry if you couldn't hear it.
Oh, no problem. I also posted the link onto the group chat in case anyone would like to stream it later. But yeah, it was extremely exciting, and I think I'm going to turn this over to Ron because he actually got to go watch it, and he's heavily involved as part of the science team in ICESat-2. So Ron, please take it away.
Okay, thanks. Let me see if I can get on here. Here we go. Uh-oh. Can you see it?
Yes.
Okay, hang on. Let me see if I can get to the... How's that? So, okay. So Melinda asked me to give a short briefing about what's going on with ICESat-2, and I was there. It was sort of at the launch. I mean, there was a marine layer, so we were quite a few miles away. I saw this flash in the distance after the countdown, and I had heard it, and then 30 seconds later was it hit Mach 1, and we heard the boom, and so that was it. So it was pretty exciting, but we didn't see as much as I had hoped to see. But in any case, we are up in orbit, and so here's the short briefing as to what's going on right now. So just a reminder, just a few slides to show you what ICESat looks like in terms of the imaging. So I think most of you have seen this. So we have, instead of a single profiling beam, altimeter beam, we have 6 beams, and there's 3 beam pairs, and the pairs are separated by about 3 kilometers. So the angle, the look angle, the incidence angle at the outboard beams are about 0.4 of a degree. So we get a broad range, a sort of a range of incidence angles, and also we see the ice 6 times instead of just once when we profile long track. So this is sort of the geometry, and so it makes validation a lot more complicated because we have to make sure that the beams are lined up in terms of height to within a centimeter or two to get the altimeter to get consistent altimetry over all 6 beams. Okay, so for those, so instead of being a regular analog LiDAR, ICESat's a photon counting system. So we, instead of sending out we send out a pulse of many photons, and we only collect a few back. And so, and I'll show later how many we're getting back for each shot. And we're pulsing at a rate of about 10 kilohertz. So the distance between each shot is about 70 centimeters. So we're oversampling the surface significantly to get the photons required to construct the waveform for retrieval of an accurate surface height. So this slide just shows the transmitted photons, so represented as some of these dots. So this is sort of photon cloud that's transmitted with a distribution, and we time the outgoing shot pulse, and then as the photons come back in, we actually time tag each individual photon event coming back, and so from that we calculate the height for each photon, and also the location coming back from the surface. So the bottom panel just shows you what the returns look like if you accumulate a number of pulses, the return from a number of pulses. So if you get a very flat surface, you get a very narrow return that's constructed using the photon cloud coming back. And if you have rough surface, obviously you have a spread, and you have a surface slope that looks like a rough surface. So the beams are used for ice sheets the multiple beams are used by the ice sheets to determine the difference between slope and a rough surface. So that's what conceptually looks like, and I don't think I'll go. So the third slide shows the fourth slide, page 4, shows the photon cloud. So this is something not from ICESat, this is from Mabel. So the top one, can you see my cursor?
Yeah.
Okay, so this is the photon cloud that comes back, and this is about 12 kilometers worth of data. And so this is the blue shows the very low photon rate from dark leads, and the sort of bluish, yellowish returns are from ice flows. And so this is sort of photon cloud. And if you look at just the leads, the photons in the leads, you can use that to construct a surface height distribution, which we use to using the cloud of photon in here to construct a distribution which looks like a return waveform. And from that, we determine the height of the surface. So this is sort of how it works. So this slide shows the spec design specification for the system. If you just look at, I'm not going to go through the CI, the ice sheet bit. I'll just look at the CI. So assuming we have a Lambertian surface, the signal coming back per shot for the weak beam is about 0.6 to 2.1 photons per shot, and for the strong beam it's about 2.3 to 8.5. And so we are actually, after looking at about 2 to 3 weeks worth of data, the system is actually performing within spec, and which we're very happy with. And so for 100 shot standard deviation for the weak beam is about 5 to 8 centimeters, and And for the 100th shot, we should get a precision of about 3 to 4 centimeters using 100 photons, about 100 shots worth of photons. And the leads themselves are obviously darker because the lower reflectance, and we get fewer photons, and we need more shots to determine to get the expected precision down to about 3 to 4 centimeters, which we're using to determine the surface height. So that's sort of a very brief summary of what of ICESat-2. So this is an actual profile from ICESat-2. This is from the Waddell C, actually. So we're very happy with the results. So the top panel shows the photon rate coming back from the surface. The photon rate is basically an expression of the reflectance of the surface. So the red is the photon rate, and the blue is background, which I don't think I'll explain the background. When we go through, so at about 5 to 6 photons per shot, this is very bright ice flows, and as you cross, so actually it's better to look at the height first. So the bottom panel shows the height, and you can see the flat leads pointed to by these red arrows. The variability of the surface in here is about a few centimeters. I guess we have to go and look closely, but initial calculations show that we can, over these very flat leads, we can get the precision on the order of a few centimeters. So the red on top basically shows where you have the very bright snow-covered ice, and sometimes in these flat leads where we get specular returns, where you have very flat surface and we get lots of photons coming back instead of a very dark lead. So sometimes you get, depending on the incidence angle, sometimes you get a very dark return, and sometimes you get a very bright return. And we like the very bright returns, the specular returns, because they're really unambiguous indicators of something that's very close to the ocean. That's probably grease ice or nihilus, and also the dark ones. So this, if you look at the top over this very flat lead here, we get these specular returns that's much brighter than the surrounding ice, and sometimes you get these dark areas here where you have leads that are actually dark, that are not exactly specular. So those are the places that we use as surface reference for calculating freeboard. So we would go through and pick out the samples that are most likely to be open water or very close to open water, and use these as references for calculating the freeboard relative to these levels. And so that's sort of one very initial example of a 30-kilometer stretch, and we have 6 of these things, which I'm not showing, across the swath for determining freeboard and where the ocean surface is located. So that's a very first look, and so this shows the timeline of interest. So the launch was on the 15th, and the Atlas, which is the instrument producing the altimeter. The name of the instrument producing the altimetry is in the mission orbit and ready. So they had to do a bunch of stuff to get the spacecraft ready, open up the door to the telescope, and get do all sorts of spacecraft maneuvers to get it into mission orbit. So if you're interested in where the orbits are, you can actually download the exact orbits over the next several months the ICESat-2 website. And so the first evaluation period, which is now, is was collected. Basically, we're starting collecting data, or mission quality type data starting October 16th, and we're in the first evaluation period at this time, and it's just a quick checkout of the level 1 and level 2 data sets for feeding the high level products. Next week, or this end of this week, we'll start evaluation period 2, and basically we're tuning the power levels of the laser and different looking at different things to make sure that the instrument is working correctly. And we're going into evaluation period 2, which will incorporate some of these new configuration changes, and then we'll go through another evaluation of the data products over between now and the end of commissioning on November 14th. So after end of commissioning, then we'll start the high-level product evaluation activities, and that will include all the high-level products from the ice sheet, sea ice, ocean, inland water, and vegetation. So there's a bunch of data products which I'm not going to show here that will be available sometime in May. I think what we're going to do is go through tuning all the geophysical algorithms, and then the reason why it's taking so long is we'll have to go through once or twice the evaluation period for the high-level products, and then at the very end we have to go back and reprocess everything since the end of commissioning to get to NSIDC. So we're planning several, probably 2 reprocessing of the data after we settle on the first set of parameters for all the geophysical products, and then that will be delivered to the NSIDC, and then will be available to the general public at that time. So it's very exciting. There's lots of data to look at, and especially for sea ice, we're planning to produce everything over the ice-covered oceans, and there are areas that I haven't looked at myself, and there, if you look at especially south of 60 degrees, and also the Southern Ocean, will be very interesting in terms of getting a good data set for validating the different parts of the ice cover of the Southern Ocean. So I think I'm going to end there now. Answer any questions you have.
Great, thank you so much, Ron. That was really, really cool. Yeah, I'd like to open it up to any questions. Does anyone have anything they'd like to ask Ron? I can jump in with questions then to start off with. So there was an ice bridge flight that happened this Saturday. Can you explain why that was significant and how that relates to what we'll be seeing with sea ice?
Okay. Oh, that one. Okay, so ice bridge was in Ice Bridge was doing its routine Southern Ocean campaign for sea ice and ice sheet, and then as part of Ice Bridge, they're also flying validation flights for ICESat-2. So those are 2 different projects. and so on Saturday, was it Saturday or yesterday? Saturday. So they flew a special mission to a special flight to underfly ICESat-2. Now the significance of that was they flew an S-shape trajectory to flight path to actually sample all three beam pairs. So they threw one track and then down up and then back down the next track and then back up the third track. Now the interesting thing about that was in order to, because ICESat basically it's about 200 kilometers worth of a stretch for each track. So ICESat takes seconds to fly that much. So in order for IceBridge to fly, it will take hours for IceBridge, the aircraft, to fly the S-shaped pattern. And so what we did was we came up with a simple correction for ice drift, so that when we go to the other tracks, the ice does not drift out of the track. And what the IceBridge folks did was, since they fly at 950 millibars, which is around 500 meters, in order to come up with a simple rule of thumb correction of the ice drift using wind and some scaling of the wind and turning angle, they descended to 500 feet, which is about 137 meters off the surface, to get a measurement of near surface wind instead of the winds at 950 millibars, which could have wind shear and other things, which makes it difficult to translate from that to surface wind for calculating ice drift. So that was the first time we tried something like that. And it seems that we were successful in tracking the drift using a simple rule of thumb scaling of the angle and the speed. So we're looking forward to having that data set to check out ICESat-2, just the comparison, because I think we can achieve approximately the same types of resolution that ATM should provide. And so I think everybody is very happy with that flight, because that was the first time we did anything like that.
Thank you. Yeah, that's really cool. So that's directly connecting IceBridge measurements with ICESat-2. Okay. Would anyone like to ask any other questions? I guess I have one last quick question. Can you speak to the temporal resolution of the freeboard product that you're making? Is this going to be a seasonal product or a monthly product? Do you know yet?
Well, you get a freeboard product every orbit. So at the resolution, basically, and there'll probably be some sort of gridded product, which will be monthly. But if you're interested in high spatial and temporal resolution, you would use the long track products.
Great. That's going to be really exciting to dig into. Thank you.
Hey, Ron. Chris here.
Hey, Chris.
Wondering, is there any, this may be an ignorant question, but is there any higher level products, like is thickness going to be processed out of this in the near future? And if those higher level products are going to be processed, can you maybe talk a little bit about like what's going to be used for snow depth and the things that are required to move from these photon counts to geophysical measurements?
Well, the photon counts will be converted to height. I mean, that's one of the.
That's the easy part. Yeah.
Well, that's actually not that easy. So then I think then we'll do the ice type ice, basically ice water classification, and we'll convert it into freeboard. So that will be a standard ICESat-2 product, is the freeboard. In terms of thickness, okay, so there's the Goddard is going to produce an ice thickness product from the freeboard retrievals. That is currently in progress and question as to what snow depth we'll use. I think they're planning to use a snow depth product that's produced at Goddard called Neos. Help me, Melinda. I don't remember what the name is.
It has a horrible acronym. It's called NISOSM.
NISOSM, right?
Yeah. And that uses reanalysis snowfall with ice concentration and ice motion. So there's still a bit of uncertainty involved when you use a reanalysis product.
Yeah, but so Chris, if you were interested in doing your own thickness product, you can take the freeboard and turn it into a snow depth product yourself.
Cool, thanks. Yeah, I was just curious what already exists, so as to not be thinking about reinventing the wheel if the wheel already exists.
Well, the wheel is not always that round. But yes, there will be thickness. There will be a thickness product, I think, by the end, some sort of thickness product by May of next year to go with the other releases. But it's handled slightly differently from the routine products that go into NSIDC.
Great, thanks.
Okay, are there any final questions for Ron?
Hey, Ron, this is Walt. Just curious if there's any plans or any thoughts towards connecting the ICESat-2 data with the earlier records, ICESat, IceBridge, CryoSat-2, for any kind of calibrations or connecting into a longer term time series at some point?
That's a good question, and I think there are certainly people are thinking about it, but I don't think there are any official plans under ICESat-2 to do this. But there are, I think, proposals out there to. I mean, there's work proposed to do that. But I think that's something that should be considered and something that needs to happen. Something that's delivered to the NSIDC.
Okay, great.
I think it's good to keep raising that point in terms of coming up with a way, a record, basically ICESat-2 record that has some sort of, that's processed consistently and processed with the latest state of knowledge.
Mm-hmm. Yeah, I think that would be really valuable. Thanks.
Okay, any last questions? All right, well, thank you very much, Ron. That was fantastic to hear the latest about ICESat-2.
Okay, thank you.
All right. So now we're going to switch gears in the time that we have left, and I'm going to see if Olivia, if your sound is working, maybe I can pass this off to you to kick off our discussion about sea ice related activities coming up at AGU.
Yeah, sure. So I wanted to go back on the agenda really quickly. A couple of weeks ago, the IRBIC Sea Ice team met with the IASC group, and we got lumped in with the ecosystems group. And just a quick follow-up from that is we were hoping to invite a speaker in February who can give sort of a background on more of this pan-Arctic collaborations, and we welcome any ideas for how to get our national IARPIC sea ice team more engaged with the international IASC group. So we're hoping to kick that ball further along. But I'm going to type in the chat box now. We have on the IARPIC site a list of some AGU sessions, and as usual, ARCIS also holds a website that lists all of the relevant Arctic sessions coming up here in AGU. I wanted to open up the floor to kind of get folks who are attending AGU or have anything that they might want to bring up with this group. Again, AGU is a great opportunity for us to touch base and meet in person. We are going to have our usual IARPIC town hall coming up in December, but I know, Walt, you had typed in the chat box as well a particular session, and I don't see that session in the ARCIS webpage, which I will also add to the chat box. So, Walt, do you have anything else you wanted to add to that session?
Yeah, just kind of following on from like earlier comment, the 40-year anniversary of the Pass Microwave record. We have a session or a couple of sessions, an oral and poster session on Friday with talks, and it's not just cryosphere related. Passive microwave has been used for a variety of fields, so it's a pretty broad session. But we do have Joey Camiso giving an invited talk on the sea ice record from passive microwave, along with several other sea ice and other cryosphere related talks or posters. So it should be a pretty interesting session, and hope folks can attend who are going to AGU. Even though it's a Friday, and partly the oral sessions on Friday afternoon, but not the latest in the afternoon. So
thanks, Walt.
Mm-hmm.
So again, I suppose there may not be a whole lot of discussion, but part of the idea, again, with this icebreaker part of our meeting is, again, to try to make our sea ice collaboration team meetings a bit more interactive. And since so many of us do attend AGU, if there's any ideas that spin up here, maybe there's still time to kind of get an informal gathering of folks if there's interest that pops up.
Yeah, I think I'd like to add to that is, since Ron gave a talk on ICESat-2, there will be an ICESat-2 town hall on Monday at 12:30 if anyone's interested in that.
Dave Bailey here. I wanted to mention that the CICE Consortium will be having a town hall on Friday at noon. I think we're actually competing with a SIPN town hall as well. So, so that'll be interesting. I guess we'll have to try to have better food or something.
Great, thanks, Dave.
Dave,
Sorry, what's that?
My computer doesn't want to stay unmuted. Did you say your meeting is also Tuesday at noon?
No, it's Friday at noon.
Okay, the SIPN is Tuesday at noon. So hopefully people can get lots of good lunches attending ice-related meetings.
Right. Actually, I think it's a search town hall, not a SIPN. So too many acronyms.
Yeah. And
Olivia, it's Martin.
Yes, Martin, go ahead.
Thanks. To my surprise, back in the summertime, I was asked by the terrestrial ecosystems collaboration team, which is organizing an AGU session on that topic with a particular focus on above and NG Arctic. They asked me would I give an invited talk to focus on placing terrestrial ecosystem research in a sort of policy context. namely IARPIC and the Arctic Research Plan, NSAR, the National Strategy for the Arctic Region, and then more broadly in the context of the Arctic Science Ministerials. So I agreed to do that. But then I may be regretting it because they scheduled my talk for 8 o'clock on the Monday morning, which I invite you to come and listen to if you care to, but I wouldn't hold it against you if I don't see you in the audience. But if you want to hear about if you want to hear from experts on Arctic terrestrial ecosystems, that session will be in the first half of the Monday morning at AGU. Thanks.
Great, thanks, Martin.
And there's another session on Wednesday called Integrating Observations and Models to Better Understand the Changing Arctic System. And there's an oral session in the morning and then posters in the afternoon.
Thank you, Don.
Olivia, it's Martin again.
Please go ahead.
More policy stuff. IARPIC and IARPIC Collaborations doesn't operate in a vacuum in its own little bubble. And so at the more senior level, or let's say mid-level, IARPIC also meets with and discusses common topics and potential collaborative efforts with, for example, US Global Change Research Program, the National Science and Technology Council Subcommittee on Ocean Science and Technology, and the USGEO group, which is also an NSTC working group, just like IARPIC Collaborations. So that group will be hosting a town hall at AGU. I can't remember the day and the time, but it may already be on the IARPIC Collaborations website. In any event, I'll check with Sarah Bowden and Meredith, since you're on the call too. You may have some details, but put that on your calendar as well as a potential event of interest to the IARPIC family.
Yes, I have just posted a link to that session. It's from 12:30 to 1:30 on Wednesday.
Thanks, Meredith.
Mm-hmm.
Thanks, Martin. I think you kind of poked at that question of what other groups are interested in connecting with us, and the fact that the Terrestrial Ecosystems group is reaching out to our sea ice group for additional expertise just points to the fact that the work that is done here goes beyond what the sea ice research community may be most focused on. And so potentially there are opportunities in the future for us to look at venues or opportunities to link with other research groups outside of AGU that just don't go to AGU. And I'm really hoping for opportunities for us, especially to link up with the community's interests. And I don't think AGU is necessarily always the best venue to get to that question. That said, the Alaska Forum on the Environment is coming up in February, and one of the faculty at the University of Alaska Fairbanks is looking for ideas even for posters or videos that perhaps we could put at the event, and that's one great way to reach at least the local Alaska communities with an interest in environmental change right off the bat. So if anyone is interested in kind of has material that they want to present at that environment, it can pull that together in short notice. Just give me an email, send me an email. Any other additional updates even? Does not have to be AGU specific.
Olivia, this is Matt Druckenmiller from
Yes,
NSIDC. I wanted to mention that on Monday of AGU at 6:15 p.m., we're having the IASC, International Arctic Science Committee town hall from 6:15 to 7 p.m. And so that's going to be updates from the 5 different working groups within IASC. The U.S. delegates to those working groups will be reporting. So that's cryosphere, terrestrial, marine, social and human, and atmosphere. And so it's not solely focused on sea ice, but there'll hopefully be some overlap in interest with those on this call. So we're going to be talking about the research being done within IASC, supported by IASC, in different ways that the community can get involved in IASC moving forward.
Great, thanks, Matt. Anybody else, anything to add?
Olivia, it's Martin again.
Yes, Martin.
If I could add something to Matthew's comments a moment ago, there are United States delegates to IASC, and they are the US Arctic Science Community's representatives to IASC. And to help with communication with the delegation in both directions, for the science community to inform the delegation and take information, etc., to the IASC meetings, and for the delegation to report back to the US Arctic research community, there is an IASC delegation workspace on the IARPIC Collaborations website. It's a so-called self-forming team workspace. So a good place to share your comments and thoughts with the delegation and to learn more about their work on your behalf at IASC. Thanks.
Great, thanks for pointing that out, Martin. Helpful to know. Anything else from anybody?
I have one more session, which is only partly related to sea ice, but there's a polar science communication section on Friday morning of AGU in the education sections.
Super. Thanks, Alice. Well, Meredith, Melinda, what do you think? Shall we wrap this up?
Yeah, unless anyone has anything else they'd like to add, thank you all very much for attending today. This is a really nice meeting.
I appreciate everyone coming, logging in today. Thanks.